This PetroSkills PetroAcademy skill module covers reservoir material balance at the core knowledge level. This section will present you with a basic introduction of reservoir material balance. One of the most useful pieces of information about oil and gas reservoirs is the size of the prize, how much hydrocarbons are present in the reservoir. The determination of hydrocarbons in place can determine future development strategies, as well as provide an estimate of remaining hydrocarbons that can be produced. In the absence of production data, volumetric analysis can provide initial hydrocarbons in place. However, it lacks any dynamic post-production information. Therefore, the uncertainties in predicting initial hydrocarbon in place are large. The material balance method is superior to volumetric analysis because it includes dynamic data. The past production behavior is included in material balance analysis, therefore it can provide a better estimate of hydrocarbons in place. Unlike the volumetric analysis method, the material balance method uses data which is readily available from the field. Unlike decline curve analysis, material balance analysis is not dependent on changes in the field and operating conditions. Unlike reservoir simulation, material balance method is simple and can be carried out using few calculations. The material balance method can provide a useful anchor point of initial hydrocarbons in place, even for operators using the reservoir simulation method. There are situations where we should not use the material balance method. These situations include the following: when reservoir pressure measurements are highly unreliable, when the field has just started production and a very limited amount of production data is available, when the reservoir permeability is very low and the transient flow conditions prevail for a long time, for example, unconventional formations, and when significant uncertainty exists with respect to the type of mechanisms influencing the production. Why material balance? Material balance is a method by which you can calculate the original of hydrocarbons in place in a given reservoir. The calculation of original hydrocarbons in place is important to understand the size of the reservoir. Hydrocarbons in place is one of the main contributing factors to determine how much hydrocarbons will be recovered from the reservoir. Without knowing the hydrocarbons in place, it is very difficult to make a prediction about how much you are going to recover. The technique material balance is popular because it uses the type of data which are relatively easy to collect and are normally available. There are two important techniques used to calculate the initial hydrocarbons in place: volumetric analysis and material balance technique. Although both techniques calculate the hydrocarbons in place, the approach used in both these methods is fundamentally different. In volumetric analysis, it is assumed that the reservoir boundaries can be correctly predicted and defined, so that the volume which is contained within the boundaries can be estimated. In many instances, determination of these boundaries can be quite difficult. In contrast, material balance technique uses a proxy or a substitute to measure the depletion in the reservoir as a function of produced hydrocarbons, and using this data estimates how much hydrocarbons were there in the first place. Let us assume that a plastic bag with an unknown number of balls weighs 100 pounds, 50 kilograms. After removing 20 balls from the bag weighs 80 pounds, 40 kilograms. How many balls were originally in the bag? We assume that the plastic bag weighs nothing. We withdrew 20 balls and the weight is reduced by 20 pounds, 10 kilograms. So each ball should weigh 1 pound, 0.5 kilograms. That means we started with 100 balls. Knowing the weight, we can now determine the number of balls. In this simple example, we use weight as a proxy for the number of balls. That is, knowing the weight will allow us to calculate the number of balls. Extending this example to hydrocarbon reservoirs, balls represent hydrocarbons, and the weight represents reservoir pressure. When we withdraw the hydrocarbons, the reservoir pressure is reduced. Knowing the difference between the initial and the new reservoir pressure, knowing how much hydrocarbons are withdrawn, we can calculate the initial hydrocarbons in place.